All right. Good afternoon, everyone. Can everybody hear me? All right. So, Assalamualaikum and a very good afternoon, ladies and gentlemen, and welcome to our highly anticipated webinar titled AI in Real-Time Operations Modeling, which will be delivered by our honorable guest speaker for today, Mr. Bradley Camburn, and he hails from the Singapore University of Technology and Design. So we thank him for taking the time to share on the topic, and on a similar note as well, thank you to everyone, to all the attendees today for taking the time out of your busy schedule to gain some valuable insights from today's webinar. I'm Muhammad Zain Sulaiman. I'll be your host for this afternoon session, and on behalf of PCSS, we are excited to have you all with us today as we delve into the topic of AI in real-time operations modeling. So yeah, before we begin, let's just go over a few housekeeping details to ensure a smooth and engaging webinar experience for everyone. So first and foremost, please be informed that this webinar will be recorded for future viewing and to distribute to those unable to attend for today's webinar. Also, if you miss any part of it or you just simply want to revisit the content later, uh, do be advised that this webinar is accessible in our official YouTube channel. So don't forget to subscribe to the PCSS YouTube channel to keep updated on the postings. Secondly, we would also like to request that all participants keep their microphones muted throughout the webinar. This will help to minimize any background noises which might disrupt the presentation and also ensures that everyone can hear our speaker clearly. Also, we highly encourage active participations from our audience, so please don't be shy, and you're more than welcome to leave any questions and queries in the chat box anytime throughout the presentation. And our team also will be monitoring the questions, and we will do our best to address them at the Q&A session after our guest speaker's presentation. And last but not least, attendance will only be shared via QR code at the end of the session together with the feedback forms. So do stay with us until the end of the session to be able to scan the QR code. Okay, so before we start, just a little introduction on PCSS. So PCSS Consultancy Sundian Bahat is a premier project management solutions provider focusing on enhancing organizational profits throughout the implementation of industry-leading practices. So with expertise spanning from project management offices, software training, integration, planning, as well as team management, we want to ensure our clients achieve sustained success in project delivery. And also backed by over 35 years of collective experience in project controls, we offer specialized solutions that elevate capabilities and maintain a competitive advantage. Moreover, we specialize in digital construction, covering BIM, building information modeling, 4D simulations, optimization of tools such as drones, AR, VR, and MR, to name a few. This emphasizes our dedication to staying technologically advanced and providing innovative solutions for the digital transformation of the construction industry in the region, as well as worldwide. So as mentioned, we offer a myriad of different services ranging from consultation, training, and software services in the field of project management. Similarly, to date, we also have partnerships with several industry leaders in their respective fields, namely Oracle, Bentley, Plus3, Exto, and ARX. And our services are also backed with the accreditation from the bodies such as PMI, SMA, APTT, Synchro, SIDB, IEM, NRCDF, Corp. So therefore, be rest assured that you'd be receiving top-notch product and services from experienced professionals, not just domestically, but also worldwide. Lastly, if you'd like to know and inquire further, don't hesitate to get in touch with us at sales@pcss.com.my, or similarly, you can just drop by our website at pcss.com.my, and also follow our social media pages available in LinkedIn, Facebook, and YouTube to keep up to date on our latest offerings. So yeah, with that being said, I believe we're all set for an informative and engaging session. So let's get back to the main event. Yeah. So, ladies and gentlemen, again, it is with great pleasure that I introduce our distinguished speaker for today's webinar. Please join me in welcoming Mr. Bradley Camber. So, a little bit of background on Mr. Bradley. Mr. Bradley joined the Singapore University of Technology and Design in the engineering product development pillar in January of 2019. So, before joining Singapore University of Technology and Design, he was an assistant professor in the School of Mechanical, Industrial, and Manufacturing Engineering at Oregon State University. He has completed his PhD in mechanical engineering at the University of Texas in 2015 and also obtained his bachelor's degree at Carnegie Mellon University in 2008. Previously, Dr. Camben also served as a chief engineer and later head of research and development at Gilmore Space Technologies, where he led the development of the world's largest hydrogen peroxide oxidized hybrid rocket engine. He has also worked as a research scientist at the Massachusetts Institute of Technology International Design Center. So his research interests include design theory and methods, systems development, prototyping, conceptual ideation, and also design innovation. So today, Mr. Bradley will share his valuable insights and review object recognition technologies and other real-time monitoring approaches that are changing the landscape of construction and manufacturing industries. So as we all know, digital twins, object recognition, and video analysis tools have recently changed the way we work in terms of operation modeling. So whereby quantitative evaluation of development progress was previously limited to the design phase, new 4D tools enable operations teams to continuously monitor the development of projects through delivery. So I'm pretty sure we all can benefit a lot from Mr. Bradley sharing session on this wonderful afternoon. So without further ado, please join me in extending a very warm welcome to Mr. Bradley Camber. Also, since I'll be passing the floor to Mr. Bradley, so whenever you're ready, just feel free to take over and proceed with your presentation.
All right, very good. Thank you so much, Dan. Appreciate it. Welcome, everyone. It's a pleasure to meet you all. I'm very excited for the opportunity to spend some time here with you today. Let me go ahead and share the screen here and start the presentation. Is everyone able to see the screen? Is it coming through?
Yep, it's all good.
Okay, all right, very good. Okay, well, I'll go ahead and jump in a moment here. Again, I hope you all find it informative. I designed this talk to be a bit of an overview, exploring some of the capabilities of AI in design, even a little bit of AI history to sort of, open the stage. And then in the second half, I'll dive in a little bit more to some of the specific strategies we've been exploring in my lab and previously in my startup in the U.S. The opportunity, as Sin mentioned, of AI and emerging this kind of visual computing space, using imagery and LiDAR data. It offers many opportunities to extend kind of the engineering and design into the whole process, right? Ways that we couldn't monitor processes before are now available. And so it offers a lot of exciting opportunities. Again, I want to start with some introductions to the concept. Yeah, for those of you where AI is new, this might be interesting. Perhaps it's a review for some of you. I'm sure we have attendees that are exploring in this space, and we'd love to open discussions to where y'all think the opportunities are. I'd love to hear from y'all what you've been doing as well. So, there's substantial opportunities to transform development and in particular construction in several ways. In the design space, design doesn't necessarily have to be, something done once at the drawing board. We can adaptively design in near real time now. So you can continue to update your designs, throughout the process. You have the opportunity to generate designs quickly, to evaluate different options that are supported by AI. Planning, you can automate logistics supports, automate
Give us a moment. I believe our speakers briefly disconnected from the Wi-Fi, from the sorry, webinar. So just give us a moment to uh, reconnect with him. We appreciate your patience. Bradley, sorry to cut you off for a while. I think you're on mute.
Okay.
All right, perfect.
Whoops. Sorry, I was on mute there. Okay, so let me just backtrack a bit. So again, one of the key thing enabling current AI technologies is of course this concept of backpropagation, right? So if you look at historical methods of simulation or modeling systems or CAD, we had to have a fixed equation. We need to know beforehand what's going to be the equation underlying that system. But backpropagation provides this opportunity where you have an open-ended system. You don't know how it's modeled, and just by iteratively refining the underlying model and reducing the error through backpropagation, we arrive at accurate models for input to output correlation. And so neural networks are really the driver, of course, inspired by human brain. And then in particular, so in the last 3 or 4 years, we've seen generative language models becoming, really a game changer in the fact that you can now automate it extremely advanced tasks, right? So I can replace several of my engineering team with LLMs. So, one of the key technologies of LLMs has to do with the concept called attention. So there was a paper published by Google scientists called "Attention is All You Need," and basically the model operates on something similar to autocomplete, right? So if you think of when you're typing, your phone prompts up the next most likely term, and with attention, the realization that they had is, they look at the whole of the output, and they ensure that the entire output, so large paragraphs of tasks, or sorry, large paragraphs of text, all have a sequence, and a composition that are related to the original input. And so it's a relatively simple concept, but if y'all have interacted with ChatGPT, so it provides this amazing ability to produce highly realistic text. Of course, it's limited by your training database. And so that's a little bit on the language basis. Another kind of interesting piece of the history here. So, in the early 2000s, there was this kind of competition about how would AI be deployed. So companies like Google had invested millions or tens of millions of dollars into producing customized, tensors, CPUs designed for AI. But some researchers at Stanford actually figured out that you could run the GPU, the neural network, on a GPU. Now, graphical processing units are really handy because they're designed to process many smaller operations in parallel. So there's this kind of emergence of the backpropagation and the realization that we could run these technologies on GPU that have enabled us to start generating some of these really advanced AI capabilities. In particular, when we talk about things like object recognition, as well as generative image production, these rely on something called a convolutional neural network. So what a convolutional neural network does is it takes an image, breaks it down to smaller pieces, and then performs a convolution, which is basically a matrix operation where you take a target cell and you multiply that cell by some value of nearby neighbors. And so, you can create some value that represents the data in a small area of the image. And this technology is leveraged in things like the DALL-E or Stable Diffusion, which allow us to generate images. So this can be quite useful in design, right? So image generation, we feed in many images. The neural network looks at, given a certain section of an image, basically what are the most likely candidates for neighboring components. So it decomposes the image space into these abstract characteristics. And what's cool is that it allows us to also generate new images by looking for combinations of sample points that may not have been present in the supplied data set. So these two technologies, right? So convolutional neural networks, which give us image processing, and the attention mechanisms, which allow us to generate reliable text, can be used heavily in the sort of design and planning phase, right? So traditionally, to explore concepts of space is expensive, right? You have to pay graphic designers, or architects a lot of money. It takes time to generate novel images, but we can generate images now in seconds based on concepts. What y'all might not know, though, is that in fact, generative LLMs are capable of doing a lot more, right? So you can provide detailed specs for an opportunity space that you want to explore, such as rendering an image for a new parking facility, focusing on green technology, for example. You can also go beyond this to actually, for instance, generate cost estimates. So we're doing a research paper on this right now, and we find that the AI is at least as accurate as humans in estimating cost and close to real world performance. We find that you can predict the cost, you can predict user problems, so what are likely failure points in the system, usability issues can be predicted and summarized using LLMs. So a lot of your operational planning can actually be done in this predictive way. And with good prompt engineering, you can get clean answers. There's also an approach called retrieval augmented generation, where if you provide a database, and we're doing a paper on this that's going to come out later this summer, using a database on prototyping to show that you can get even more accurate responses. So if you have, for example, a repository in your organization of past project costing, you can retain that locally on your machine, feed it to the AI, and use it to automatically generate more accurate, to generate accurate bill of materials. But of course, you can use this as well for planning, legal issues. So many tasks. We did a study showing you can estimate performance, right, such as carbon emissions. So we say, even with a very simple description of a building, you could estimate the carbon emissions during construction or operation. Okay, so you can other challenges like material selection, right? So if you have a particular load case or environmental conditions and you want to pick a material, you can use LLMs to provide a selection of what material you might want to use. You can even, although this capability is still nascent, you can even provide a prompt and have the script have the LLM generate a script for CAD. So this is a paper from a colleague of mine showing that you can provide a description of a design and it would generate the actual CAD for you using an open source example here where the CAD can be generated from a code series. So there's a lot of capabilities. In our university, we focus heavily on design innovation, right? So this is a class I teach. We had 550 students last year, and they go through the whole design innovation process. So they do user studies, they do concept generation, storyboarding, journey mapping, then they create sketches and a final prototype. One of the time-consuming activities here is to generate a storyboard. So here's a hand-drawn example. Again, the story is consistent. It's kind of clear where the character details are. But again, we also found many teams successfully replace these human-made storyboards with AI-generated storyboards, right? So you can specify an artistic style, show different sequences of the development process, and basically automatically produce a storyboard for a process or user interaction. Okay. It's not always perfect though. We find that, again, sometimes in generation. So here's an example that it was not as cohesive. This team was working on a safer road crossing technology. And you notice they have a robot here. And if you actually look at the robot in these different frames, it changes. So the generated images actually were producing a different robot. So it wasn't as consistent. I recently had a case where I was trying to generate an image. I wanted to show a tank with cameras pointing inside the tank. And despite despite several conversations with the AI, I wasn't able to produce a version with the cameras pointing inside the tank. It would only produce images with the cameras pointing outside. So there is a lack of control to an extent over what can be done today. But again, there's still pretty extensive capabilities. Moving away from LLMs, and you look into the generative design space. So this is another former SUTD colleague who they have a startup now called Digital Blue Phone. So again, these are AI-based technologies, but also in the generative design space, right? So Digital Blue Foam, you can generate plans, building plans based on the site analysis. So nearby buildings, required transit pathways for the residents of the buildings, generate many different not just variations that are parametric, but as you can see, kind of foundationally different concepts for the building and automatically assess the evaluation. So there's really a lot of rapidly emerging tools that support the generative design space. And it kind of proceeds throughout the whole process, right? So from concept to planning, I didn't include one here, but there's another colleague who has a software where you can provide example images for interior design that you like, as well as an image of that room, and it will generate specific interior design plans for that room. So the whole design process can really be supported. Another area where AI is bringing down the cost and time of design and enabling us to use it more regularly throughout design is in the simulation space. So physics-informed machine learning enables us to use AI to replace physics-based simulation. So simulation is an area where my research it has been heavily focused over the last half a decade. And if you look at something like computational fluid dynamics, this simulation can take hours or days, as well as require a lot of expertise. But there's several emerging technologies that allow for basically real-time simulation. So this is an example called regression forests. So you can actually, so this is real-time. So if you don't believe it, you can go download their demo. And these are physics accurate simulations of CFD based on, modeling the interactions of kind of local materials. So it kind of looks at a state within a small region here, and then based on the conditions in that state, it determines what's the most likely transition state using a regression forest to basically achieve real-time physics simulation. So what this allows us is an ability to actually incorporate physics simulation throughout the design process, or even during observation of construction or operational procedures. We can look at modeling the physics in real time, because again, you don't necessarily have to uh, build these very very expensive models. From planning space, I won't have as many examples here, but there are a lot of amazing tools provided in the sort of administration HR space to support things like project scheduling, cost estimation, risk management, resource allocation, supply chain. I have another colleague produces a product called Be Productable that basically, provides this sort of automatically generated project overview, right? So you can see what's the progress of the project throughout the span of the project, and automate decision making. We've seen AR and VR for training and repair and replacement, automated chatbots to provide real-time guidance and support on site. And then, yeah, so let's jump in on operations. So I'll talk about a couple of the overview capabilities, and then some of what we've been doing in our own research. So, things like drone mapping, Zin mentioned, I think PCSS supporting this, LiDAR modeling, all allow us to get better imagery of a site. And then we can do things with that. So we could recognize objects, we can create physics models of the site to actually monitor the progress automatically, as opposed to through purely human processes. Um, Logistics on-site support, although the infrastructure investments are more, we see Spot, being deployed in many construction sites around the world to, do LiDAR mapping, right? So you can send Spot out on your site to go give you more real-time, up-to-date LiDAR maps. Another company I had, briefly been communicating with last year, Agility Robotics out of Oregon. So they produce this robot Digit, which is capable of doing many autonomous tasks. Or you can see, Amazon's, warehousing workforce systems, which is very, very automated. So increasingly, it's not shown here, but there's some researchers in Northern Europe, showing autonomous construction vehicles as well, right? So like in automated backhoe or other equipment like that is now trending towards full autonomy. So you can imagine, linking together autonomous robots as well as site monitoring. A couple of organizations also offer ability to track workers, right? So one solution I've seen uses in-helmet Bluetooth tracking, so you can monitor worker efficiency, right? So understanding our workers on site, which site are they on, where are they located, which can be used, of course, for facilities and resource management, making sure there's not too many or too few workers located in one facility, as well as even using some intelligence on top of this to predict potentially hazardous conditions as well. Physical configuration audit, right? So some current processes would require us to have an inspector go and physically measure a variety of sample points. So drones can be used to capture, video or LiDAR scans of the facility space. There was a conference last year where I met PCSS, and we started talking about, could we potentially deploy some of this simulation technology I've been working on, with their cases, and we saw some really exciting companies there as well, supporting, for instance, like a semi-autonomous auditing, right? So they have a map of the facility, on an iPad. You walk around, you can just snap a picture, and instead of having to do a paper report. So there's fully autonomous and semi-autonomous solutions that are emerging in the market. So just want to talk about some technology. So LiDAR, light intensity detection and ranging, gives us the ability to build a spatial model of facilities. So you can do a lo-fi version on your phone. There's more expensive equipment out there that gives you more accurate models. But what's wonderful about LiDAR is that it lets us bring CAD kind of beyond the design phase, right? Because it produces a 3D spatial model of the building, right? So you can monitor the final build. Was it built accurately? You can even monitor the process to see where equipment is being placed, as well as what's the degree of progression over time. As the building ages, you could even monitor, creep or sagging to determine if the facility is becoming compromised over time. Is an alternative to LiDAR. Some of you may have heard of NERFs or neural radiance fields. So technology developed out of NVIDIA. If you don't want to invest in, kind of the more expensive or kind of complex challenge of deploying LiDAR on site, although the cost will come down there, you can also actually integrate image data to produce 3D models as well. So that process can be automated through AI, although you still need multiple angles. And then a little bit about what we can do with some of these. So to differentiate, there's object detection. So what object detection gives us is basically a box or that has a centroid and a dimension. So you can train to identify certain objects. One of the challenges here is that you're limited largely by what training sets are available. There are a few for construction, but object detection gives us the location of key elements on site. So, it could be workers, it could be placement of key machinery. Another approach, which is useful in some other scenarios and perhaps slightly more precise, is called scene segmentation or image segmentation. So unlike object detection, which gives us the position of key objects, scene segmentation characterizes all of the 2D or 3D data within a scene to show precisely whether that area of the image corresponds to a certain type, right? So here, you're identifying different columns. You can also identify different types of artifacts and segment them. Scene segmentation is useful because you could, for instance, determine what percentage of an area is out of alignment, or what percentage of an area is covered or uncovered, for instance. And so it can be useful in more quantitative calculations that allow us to assess and evaluate and take more measurements of the space. Okay, so with that, I'm going to jump in and talk a little bit more about, so these have all been kind of generic examples as well as some of our work from class. I'm going to talk a little bit about some of my own research now. So I have worked as a designer in the systems integration space. So, several key projects. We worked on designing some manpower facilities for Singapore, worked on the Singapore Founders Memorial, on developing a set of design guidelines for one of the new railways here in Singapore. At Gilmore Space, I worked on developing several test facilities for their engine program. And so some of the interesting things that we can, look at is how might we use, synthetic data generation, simulation, scene segmentation in this space. So again, so BIM data can lack a direct connection to site data, right? So a challenge is that we, are trending towards having these highly accurate models of buildings, both of the structure and conduits and different services provide within the building, but we lack an ability to really understand what may be happening on site, what's the progression of build, how those facilities differ. And so one of the research technologies that I've been working on is what do we do if we want to scan a site and detect certain objects, but if we lack if there's no training repository for the particular objects that we're interested in finding, you're kind of out of luck, right? So there's a limited set of training cases out there. And so if you're developing a factory or if you have customized equipment and you want to detect it and know where it is, there's really no technology that supports that. So in a research project, starting at Oregon State, I had developed a series of tools that lets us actually create customized object tracking tools. So we have a software that will take CAD data and convert that into synthetic LiDAR scans. So we basically automatically generate data which looks like what you would find in a LiDAR scan. And this has to be kind of standardized using voxelization, right? So both in our training data and our synthetically generated data, you need to standardize the density, right? So we use a voxelization smoothing process to get standard scan and training data, which we can also upscale later, right? So there's methods and technologies. This is from a Google paper, so I didn't have the citation here, but you can actually degauss noise to increase the resolution, so we can downsample and upsample the data as needed. And what we're looking for in order to be able to train object detection is this kind of intersection over union, right? So the way it works is that you have basically a template that shows like where, which block of an image cor most corresponds to a certain piece in the training data set. And so that's what it's kind of sampling. But you need a neural network to do this. And so we feed the neural network basically a ground truth data, which is the segmented image, showing which pixels in the image correspond to which type of artifact. And then we also have the original unsegmented scan data. So whenever you're training image segmentation network, you need to have this labeled ground truth data. So the kind of standard solution is to go to industry data sets that are open source, but we have an ability to generate synthetic data sets. So that would give us the replicates of what the scan data would look like, as well as the automatically labeled ground truth data, which we can then apply. So this is a simple example, from a driving demo, but this is the kind of segmentation data that you get. But here, this training data set is limited to things relevant to autonomous driving, right? So you get kind of building, tree, or car, or roadway out of this. But so again, we built a synthetic data generator. This is an example, kind of producing different configurations. So in order to train for detection, we have to produce lots of different orientations and configurations of target artifacts. And then here's an example, right? So we use synthetic data generation, and we detect within the facility scan where are basically different features of a site, right? So like structure, tank, or tank cap. And so again, useful in the sort of, especially wherever you have any customized machinery. If you're building complex, indoor, manufacturing, or if you want to also monitor operations. So this is sort of what our tools support offers. The second piece of the research we've been working on in my lab is how to incorporate physics data. So again, taking some of these AI-driven data methods, simulation methods. There's a couple of techniques. So many of you may be familiar with neural networks. So with a neural network, you can predict design performance. So the kind of state of the art, this is an example from a paper I wrote with some colleagues. We were designing ion thrusters for in-space propulsion. Really cool technology. They can produce up to like 100,000 meters per second exhaust velocity in space. But the simulation can take hours, right? So we built a tool where we could take physics, take the design, and then we had a physics simulation that would tell us what's the performance of a given design. And we could train a neural network to predict what the performance would be based on that given design, which is really cool. But it has a limitation, though, that you kind of only get a single point, design performance parameter. But in the recent years, so we've been working in my lab on new technologies, and there's been a few other authors doing this, but we have some novel approaches to this, where basically you can take image data and use neural networks to, or basically convolutional neural networks to build predictions of how that physics simulation would progress. And what's cool about this is that you can actually get spatial, data, right? So you can actually emulate fluid flows, you can emulate stress, or stress in a system. And again, it can operate on several orders of magnitude faster than FEA. So because this is being recorded, I can't show the actual example, but when I was working at Gilmore Space, we did some really cool AI-driven physics simulations of the rocket combustion process that enabled us to rapidly model the engine interior and overcome some of the limitations that had been present in the industry by a simulation that would have taken days with ANSYS. We're able to reduce down to seconds and explore different designs for the engine than would have been possible otherwise. And so some of the research I'm working on currently, and definitely open to find collaborators, is illustrative, but basically taking video data of the site, connecting that to the spatial modeling, and also overlapping operations, right? So kind of taking site data, detecting what's there, and then producing physics simulation is the sort of direction that we're headed with my research. So you can identify, either unsafe conditions, as well as kind of efficiency modeling, as well as process modeling. Okay, so again, I hope that was interesting. I think that's kind of all I have. Again, a bit of an overview, which I hope is perhaps informative, but kind of how and why AI has been able to take off in the last few years. So, what are some of the technologies that it leverages, as well as what's some of the research that we're doing. Okay. So let me exit the slideshow, and then I think we have some questions to throw out. But are there any questions from the audience, maybe before we go into our prompted discussion?
Yeah, if anyone has any questions, do feel free to type them in the chat box provided.
So I know y'all are muted, but if you type out, would be happy to reply.
Yeah, perhaps I can just get the ball rolling by presenting just a question that I would like to ask. So what are the ways that what are the ways that you are currently using AI in your organization as of the current moment?
So this we're throwing out to the audience. If anyone are any of y'all using AI now, and in what ways? Or maybe you
Perhaps
don't
it's
want to
still
share.
a foreign
Okay.
topic in our current industry at the moment.
It may be an emerging area. I think, as you've seen, a lot of the technologies are emergent. So again, if y'all are interested, this is an area where we have a lot of strong research and development here at SUTD, both in the architectural side, in the physics and simulation side. So I have a partner who's an architect. We do some projects on building and construction monitoring, right? So both from construction and the manufacturing frame of reference, as well as, from a physics simulation standpoint, we're doing a project modeling, quantum processes as well as nonlinear deformations. So, AI can really support monitoring as well as simulation, and go beyond what the current state of the art, kind of standard simulation tools can offer. So there, if anyone's interested to to learn more, or you think there's an opportunity to connect, we're open to development as well. So if there's, maybe we go to the next question. Let's see if anyone. So if there's none on that, I mean, we had a second question. So if you're able to, wave a magic wand and have sort of any AI-driven capability that you wanted, is there anything that y'all would like to see, or would it be interested in seeing developed? So from Mohammed, we are currently looking to forward and expand the use of AR and VR, but it's still in progress. Absolutely. I have an interest in a project going, in the AR VR space. So connecting some of this kind of object tracking and recognition to AR VR. So definitely feel free to reach out. There's an opportunity to, of course, make the access of your kind of 3D and 4D information much more smooth using AR VR, right? Especially Apple Vision just kind of released their product in Southeast Asia here, which has wonderful tracking capability. So there's opportunities there for sure. I think there are implementations of AI in the construction industry. One of them is generative design using AI. Yeah, again, absolutely. Generative design using AI, it's not just restricted to creating, kind of cool concept sketches, right? But you can actually create build plans. You could, get it to prompt you, what's a list of regulations I need to be aware of to develop a certain type of building. To comment on or modify your build sequence. So it can actually do much more than just generate concepts for the ideas, but actually generate a lot of the supporting materials as well. And give feedback on your planning and strategy. And okay, next question. So oftentimes people mistake AI with IoT. Can we clarify on the difference? So AI, of course, stands for artificial intelligence. IoT stands for Internet of Things. So the two, they are closely related, right? So the Internet of Things refers to basically distributed sensor networks, right? So like the example where we have Bluetooth in a worker helmet, that's really technically more IoT, right? Because so IoT is a method of data collection, or also synchronizing multiple autonomous agents, right? So you might have multiple robots on a facility inspecting or doing some operation. You might have monitoring of workers. So IoT is really basically sensor data collection or control, where AI is, whether you're using neural networks to, model behavior and extrapolate. Might use a neural network to say, oh, if I have 10 workers clustered around this moving vehicle, maybe that indicates it's a dangerous scenario. There shouldn't be too many people so close to it, for instance, right? AI is what's used to interpret the data to draw some intelligent conclusion. So they're definitely connected, but they're slightly different. Very cool to hear that y'all are doing optimized project management. We had a couple of design consultancy projects we did here with Singapore government, looking at how to support like HR with AI tools, right? So chatbots, you can use ChatGPT, but you can also create those that are customized to your project. You can create workflows that also automatically produce project documentation. So, invoicing, procurement, all these things that kind of eat up everyone's time and can be kind of a bore, can be also automated. Um, Question about how much is the cost involving for using AI in the operation? It's totally varies, right? I mean, ChatGPT license is $20 a month, but if you want to build a custom ChatGPT API that provides customized solutions and does like a deeper, and you retrain their model. I have a colleague working in the medical industry where it's costing them like 20K to totally retrain it. So even something like ChatGPT has a lot of varying costs. We do R&D projects that depends like, I have some tools that are already built, or, if you go and do research and development, they can take more investment. Things like object tracking, um, you could use pre-existing tools that aren't that complex, but maybe it just gives you object location. You don't get to do anything with it, right? So you need to build in some research and development costs to be able to maybe build a framework. How do you detect scenarios that matter? How do you deploy it? So although the access to software itself may sometimes be even free or not super costly, it's like training and custom software development. So you can look at any kind of software development scaling costs. It will give you an idea. Yeah, so with generative design using AI, it is now shifting more towards choosing the design than trying to think of one. I agree. There is also, it's a fascinating thing with generative design and the toolkits that you have to be a little aware of, is that there's also like this tunneling effect, right? So if you go onto YouTube and search for a pop video, but maybe you prefer a jazz, like once you've searched for pop, all your recommendations are going to be in that genre, right? So the same thing can actually happen with generative AI as well. So if you start producing certain chains of images, so sometimes you have to be careful. You have to kind of either start a new chat or force it to generate different variations. So I think there's still a bit of a ways to go, but of course, things like digital blue phone, like my colleague has been working on, there are toolkits for say within just architecture to provide you variations on generative designs. So it depends, but I think it's a very powerful opportunity. Off scope question: is AI still known as artificial intelligence, or is it now known as advanced intelligence? I like this one. Um, if you ask ChatGPT whether or not we've reached the singularity, it will say no, but I don't know if I agree. I think it is advanced. I would say if you're an expert in something and you go to an LLM and you prompt it, you'll probably find that it gives a really good answer, but that you'll notice you could add more detail. So I think what's amazing is that it's a one go-to point that's kind of knowledgeable about any given particular topic. But I think, again, we see AI has beaten humans in all of the competitive games, right? So it is whichever version it's going to be, ChatGPT 5, 6, or 7, eventually, it'd be difficult to disprove that it's not smarter than a human already, right? And so I think, one of the ways the landscape of almost every industry is changing is that you now have to really think about how can I wisely use AI in my organization, because if I'm not doing it, my workflows are going to be so much slower compared to competitors that are doing it, right? So it's a very powerful tool. So we have to kind of think about how do we look at A to Z processes in our organization and see where we can use AI to optimize it. And that's why I kind of brought in, PCSS and in my own research, are doing a lot with 4D, but you can do so many things with it in planning as well. Based on the presentation earlier, the application on construction are all the examples on structure. What about for road highway construction? One of our projects do have BIM modeling, but only limited to station architecture. The difference between these two projects is building construction are more localized, while road construction are more vast. So that's a great question. Um, Definitely, one of the challenges with using this sort of object recognition, LiDAR scans. So a LiDAR scan of a building could be a terabyte. So if you're talking about a LiDAR scan of like a 100-kilometer stretch of road, this could be thousands of terabytes. In order to address that, there are strategies where basically you can downsample the data, and that's what we've done in some of my own research. Or you could build basically you could design. Well, I'm trying to think about how you would design this. Maybe you would have a drone or a scanner on a vehicle with some processing built in, right? So you're scanning and then detecting certain conditions as you go, rather than trying to store the entire data set and transmit it back to a facility. Because it's true that if you were to try and store the scans for very long, very, very large structures, the data size does get unmanageable. It depends what you're looking for, right? Like if you wanted to archive the project, um, again, there's ways that you could still streamline the data demands of doing that. Yeah, interesting problem though. I'd be happy to chat more about that. I'm very interested in the topics. Will the PDF of the slides be available? I think Zin mentioned I think they're going to post the video. If you want a copy of the slides, you can reach out to me or Zin. Some of it, there are a couple of slides that aren't published, but I removed all the stuff that was super sensitive because this is going on YouTube. But yeah, feel free to reach out to us. Hi, can AI help in prioritizing and scheduling in project management? So it's a good question. So prioritization and scheduling in project management, there are automated, scheduling tools. I'm not an expert, but on what's in the market right now. But I know we've worked on a few tools with, AI and HR where basically it might help you to prompt workers to, have they completed a task, to sort of follow up or to automatically monitor systems requirement progression. Um, the only thing, and prioritization, and so you could absolutely provide a list of tasks and say to prioritize them. But with decision making, you do still want to be cautious because sometimes the information provided or the suggestions given are not perfect. So you want to come up with a workflow where you automate some things, but then still evaluate it. But absolutely, you could go to an LLM, throw in a list of tasks, ask it to help you prioritize, and it will do it. If you have more complicated schedules or you need to manage more detailed documents, then you may need to look into producing either custom software or finding a developer that has something. But it has, yeah, there's work in that area as well. These are all great questions. Um, okay, yeah. So following up on the roadway scanning. Agreed, when they scanned the area for one of our project, the amount of data was significant, hence only one station was carried out. Interesting to see what type of solution can be done to address this in the future. Yeah, basically, I would take two approaches to it. One is, you could scan, um, then do a detailed analysis based on the high density scan, and then downsample it to store. So you still have some like version, you downsample it from a terabyte to a gigabyte. So you still have a piece of it to know what it looked like, kind of before you downsampled it, but you could do analysis on the higher fidelity version before you delete it. I mean, you could also develop an approach. Um, I haven't done this, but it'd be an interesting thing we could look at doing is like you have a standard repository, right? So instead of saying, here's 10 million points that represent a roadway barrier, we have a model of a barrier and say like, okay, this is a standard barrier. And then if there's like a deviation, then you can store only the deviation so that you have a way to basically store only the critical data. So yeah, basically coming up with like a representation scheme is one way, or just doing an initial analysis and then downsampling could be two ways you might do it. Great. Cool. Love the questions. Awesome. Great engagement. Again, very exciting stuff. Sin, how are we doing on time?
Yeah, we're on course.
Okay. Good. Okay. Well, I don't know if there's no other questions. Again, I want to thank everyone so much for your time and engagement. This is a really fun topic. Oh, wait, one more. Okay. My organization is an ISP provider. AI automated system is now being deployed as intelligence tools to gather millions of connections of performance and predict future users' connection failures. Um, Kind of a head up warning for the ISP provider of a particular connection that may fail and how to act fast and overcome it. Yeah, that's really cool. System health monitoring is something that, so we have another department in the called engineering systems, ESD, and so they look at a lot at like how do we monitor complex systems. And yeah, AI has some really cool capabilities in the autonomous like health monitoring of digital systems as well. That's not as much in my area, but I think again, there's so much that can be done there. I was at another like like a media conference last week where they're doing all sorts of cool things there. So again, the ability not just to say, oh, is one sensor off, but is there a trend, in multiple data points that indicates something might be going wrong. Um, Very cool. Question: will 2D drawings be obsolete as BIM and AI tech continue emerging? Wow, that might be a better question for Zan than me. But I guess one thing I would say is that there's always a value to a 2D drawing. Especially if you still want to have a human on site to go, and evaluate a build. It's like it's valued to sometimes have low fidelity information, right? That allows you to do like a quick check. Does this thing look kind of like it should? Even though you can do it autonomously, and the data draw is lesser. But what's kind of interesting is that AI also offers this ability to transition between 2D and 3D. So you can actually provide a 2D sketch and ask it to generate a 3D image, right? And then, of course, BIM allows you to kind of automate the process of going from 3D to 2D sketches. So I think, 2D drawings, 2D data representation is easier to digest. So I think it's always valuable to the human. But the barrier between, going from 2D to 3D or from 3D to 2D is definitely getting narrower. But I don't know if Sin has comments on that.
I think I completely, concur with what you say.
Good. Great. Thank you,
But yeah,
guys.
maybe I have a question of my own, perhaps. How we engage in like developing new AI tools and workflows, like what capabilities like would be useful to like organizations in general?
Hmm. So there's two levels of AI development, and I think for most organizations, what makes sense is to have a sort of AI engineer, and maybe I'll make a plug for. We just started a first in the world program here at SUTD called Design and Artificial Intelligence, DAI. So it's kind of a architecture plus artificial intelligence plus product design career where students learn a lot about AI, they learn a lot about engineering. But anyway, so we have some fresh graduates. So hey, feel free to keep an eye out for our DAI grads, but it could be from anywhere. But I think many of the tools are done, right? Like it wouldn't make sense to necessarily go rebuild ChatGPT from the ground up in your organization for a lot of applications, right? So having an AI engineer that can develop prompts, that can customize the toolkits to your organization is one. There are other times where having key partners that can do customized development is valuable. But through a consult, honestly, it probably makes sense most of the time, to outsource this or customize or to develop long-term research partners, because when you look at training, really advanced data sets, sometimes you can do it with like a desktop, a very high-end performance computing machine, but most of the time you need supercomputing infrastructure. And there's a lot of it's challenging, but the machines for deep learning to train really advanced neural networks, LLMs, they're running on these NVIDIA GPUs that are like $500,000 to $1 million each. And it's changing every year. It's not just the cost of the equipment, but also it's sometimes very non-intuitive to conduct training on supercomputing clusters. Some of the simpler training you can do on desktop machines. Like we've done a number of studies where we use just like a very high performance machine, but generally you're kind of limited by the infrastructure, and so it probably makes the most sense to hire an in-house engineer who's capable, competent and familiar with the existing toolkits, and then learn how to integrate them. I saw someone raise a hand. Chi Long, do you? I think we've disabled the mic. Are you able to type out your question, or? So I saw someone raise a hand. Did I miss one of the?
I think it was like Peter from the floor who raised.
Oh,
Yeah. But if it was a misclick, then
maybe
probably
it
the
was a
case. But
mistake.
if you do have a question, feel free to type them in the chat box.
Very good. Very good. Yeah, cool, exciting. I mean, again, I think the opportunity to blend the site models with physics models is a really, really exciting space. We've got some work going on there. So if it's of interest to anyone, definitely link up with, I've been talking to PCSS, so, maybe we can always team up to help you guys, their construction expertise, and some of my research in AI. So open to find partners that are need help on a project, or if you just ever want to chat more about what AI can do, happy to connect with y'all. Good. Any other questions, comments?
I think we'll just have one more question from the floor. There's one from TS Adrian. He says, as AI use increases, how to cater with the cybersecurity threats, if any?
Oh, this is a great question. I had actually worked on a cybersecurity project a few years ago with it in the U.S. government. I can't say who, but it was a pretty cool systems. Cybersecurity, depending. So firstly, it depends on the criticality of what could go wrong, right? So if you're running maybe an energy plant, it should be absolutely a huge priority, because there's going to be cyber attacks to your infrastructure, and it could represent huge risk. There's lots of different, if your infrastructure is not something where security is as big of a concern, you may not need to worry about it. But some strategies are like having physical analogs, right? So if having this sort of like manual overrides, right? Avoiding the complete autonomy of systems, right? Still having a human in the loop, right? Like if you have an automated construction vehicle, make it a requirement that someone's still watching it, right? And can have a hard, disconnect to flip it off, right? So I think the important thing is that autonomy brings potential reduction in workforce, in sort of manpower costs, make everyone's lives easier. But anything that has control over physical systems, you really need to make sure you bring in experts in system design that know how to design fail safes. When it comes to design, I think, although more subtle, there's still a risk there that you can rely on the AI to generate, say, a set of user needs. Like, say, I have a student designing a backpack, but like, will they design it for the entire population, right? Like, would they consider the needs of users with disabilities? Or, well, if it's not in the training set, it's not going to be there. So, from a complete autonomy standpoint, you want to have fail safes in place from the sort of design and research perspective. It's important to be aware that these are just like the most probable answers, and they look very much like they are created by experts, but they could easily miss something, so you still want to have human verification in the loop. It's a good question though.
All right. So yeah, I guess that's all we have for our time for the day in terms of the question. I do notice that there are perhaps a few questions that might we didn't have time to address them, but don't be rest assured that we can address them individually after the webinar, as we have your emails and we can send them to the speaker and he will individually reply to your queries. All right, so yeah, moving on with the webinar agenda for today. So, ladies and gentlemen, we've just been like treated to an insightful presentation by Mr. Bradley, the wonderful Mr. Bradley, on the captivating topic of AI in real-time operations modeling. I think I can also speak for the majority of us that Mr. Bradley and his team at SUTD are researching and creating not just innovative but groundbreaking solutions to propel the construction industry with the usage of AI. I think not only the current applications that were presented very practical and applicable in various project delivery stages, in a various different industries as well, as shown by Mr. Bradley, but also the possibilities that emerge, particularly in the construction industry, is one I believe that we can all look forward to, and even more so as we're moving towards the Industrial Revolution 4.0. So yeah, on a similar note, I'd also like to extend the biggest of gratitudes to Mr. Bradley in taking his time in compressing the vast information of AI and its applications into a more digestible form for our audience. So yeah, all in all, again, I'd like to thank you for shedding much light on this topic. All right, so in wrapping up our exploration for today's webinar, yeah, a special thank you again for sharing your valuable insights. Any parting words before we present you the certificate of appreciation, Mr.
Oh,
Bradley?
I'd just like to say, again, deeply appreciate, you're including me in this. I think the work that y'all are doing is fantastic as well, right? And the 4D design is definitely, the future of building and construction. So thank you all so much for bringing me to speak today, and I look forward to, hoping to connect with all of you further in the future and keep the conversation going. Thank you.
Likewise, it was much appreciated from our part as well. All right, so here's the certificate giving. Okay, so before we end our webinar, so let's capture a special moment with a virtual group photo. So if everyone can switch on your webcams and we can take a group photo together. While we can't physically gather, we can still create a memorable snapshot together. So perhaps in the count of three. So one. So 1, 2, and 3. Or perhaps just another one, a freestyle one. So in the count of three. In 1, 2, and 3. All right, great. So yeah, before we depart, we would also like to share some of our services on behalf of PCSS. And if any of you have any interest in our demo on our services, we just share our screen first. Okay, so here's a few of our trainings that we offer. We offer various training ranging from synchro as well as planning, software project management in P6 as well. So if you're interested in any of these offerings that we have, feel free to contact us at sales@PCSS. And similarly, we also have upcoming events as well. The Borneo ADR Week 2024, I believe, is on the 18th of July. So yeah, you can just scan over here, or alternatively, you can just go to our social media pages as well as our website to gain more information on the event at hand. Okay, so once again, thank you very much to our honorable and esteemed guest speaker for today, Mr. Bradley. And also, I would like to thank everyone for your participation for today. It's made the engagement a much more valuable one, and I'm pretty sure we've all gained a very insightful and invaluable knowledge from our esteemed guest speaker today on the topic of AI. So once again, thank you. And yeah, have a nice day and a great weekend, everybody. And also, yeah, the attendance for the QR code for the attendance will be displayed right over here. But yeah, once again, thank you and have a great day, everyone. And assalamualaikum. And yeah.